The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Here, example Hess's Law. It's asking us, what is the standard enthalpy for glycolysis? Here's our reaction here. Now, to find the standard enthalpy of glycolysis, all we need to do is we just need to take a look at these individual steps and rearrange them to get the reaction that we need, that being this up here. Wonderful. Now, to do that, we can leave our first reaction alone, and then the second one, we're actually going to have to flip it, and we're going to have to multiply it by 2. It's a trial and error method. Sometimes you may have to do it a few times just to ensure that you get the reaction that you need. Now, when you actually flip the reaction, you also have to flip the change in the standard enthalpy change as well. And what I mean by flip is you're going to have to change the sign of the standard enthalpy change. Furthermore, if we're multiplying the reaction by 2, we also multiply the standard enthalpy change by 2 as well. I've actually gone ahead and made the necessary adjustments to this. Let's go to our next slide and take a look at that. Perfect. And here we see that the following reaction is multiplied by 2, as we had said. It is flipped. Furthermore, the standard enthalpy change, as we see here, it is positive now, and we also have multiplied it by 2. Now, what we can do here is we can cross out everything that we don't need, our carbon dioxide, our oxygen, right, our water, and we're left with our glucose here, right? Furthermore, we also have our lactic acid here as well, right? And once we just finish writing this here, COOH, solid, and the standard enthalpy change, I'll just write it down here because we are a little limited for room, is going to be negative 120 kilojoules per mole. And there we are. That's our answer there. Now, if we take a look here, there's 3 things that we can learn from this. Firstly, the negative sign again is telling us that the energy is being released, right? Secondly, where is that energy being released from? It's being released from the bonds. Now, how is that energy measured? That energy is measured through the heat transferred in a calorimeter. Wonderful. Let's now move to our next slide and take a look at our next example. Wonderful. And we'll begin here. Example Hesss Law once again. What is the standard enthalpy change for step 1? Here we have a reaction where we're given the standard enthalpy change for the reaction, but we need to find it for step 1 right here. This example is exactly like the one that we had just looked at on the previous slide, but with a slight twist. And all we're going to need to do is we can write down our standard enthalpy change equation and just isolate for the value that we need. Let's go ahead and do that now. And we see here that for the reaction, that's just going to be the standard enthalpy change for both of our steps, step 1 and step 2. And what is it that we're looking for? Well, we need it just for step 1. Let's go ahead and just adjust our equation and isolate for the standard enthalpy change for step 1. And in doing so, we end up with the following equation. Great. Since we're a little limited for room here, let's pick this up now on the next slide. Great. If we take a look here, this here is the equation that we had left off with. Let's go ahead and pick it up from here. If we go ahead and we just write in our values, we know that this is going to be negative 120 kilojoules per mole, right, minus negative 2,688 kilojoules per mole as such. And once we go ahead and we equate that, we see that we get a value of negative 2,808 kilojoules per mole. And that there is our answer. Great. Let's now move on.